All right. As part of this week, we're going to talk about the weather where we live too. We just gave you a video, and part of what you're learning is planetary circulations. Well, let's bring that down a little bit smaller scale. Uh, the smaller scale being cold fronts, warm fronts, high pressure, low pressure. And if you do that currently, this is actual forecast of what is going to happen in the next 24 hours. So currently, we have a stationary front along riding through Missouri, Kentucky, northern Tennessee, into Virginia and West Virginia. North of that, we have high pressure. And day two, front kind of wobbling, but a weak low is moving along it. Cold front coming in from the northwest. Interestingly, the yellow lines indicate potential for severe weather. By day three, we have a decent cold front moving through the eastern part, through Ohio and all. So this would be on Tuesday, moving forward. And if you go a little bit further out, day three shows it Wednesday, the front moving off the East Coast, and this high, which is Canadian air, moving in from the northwest. And by Thursday and Friday, it settles right over most of the eastern United States, actually pushes the front off the coast and down to the south. So let's look at what this means in terms of what you've been learning about. So we're going to look at the slideshow here a minute and go from the weather systems in the mid latitudes. Well, what type of systems shape that? A couple of the original observers of East Coast cyclones were Ben Franklin, Daniel Defoe. They tracked them up from the south to the north and learned, wow, these systems develop down here and wind up hitting us. So between these systems are air masses. Air masses are much bigger than any one individual low typically. Air masses are going to form where land, water, they have similar things going on. For example, we get a lot of air masses out of central Canada. The one I just showed you this week will be coming out of that area as well. Why is it? What kind of an air mass would that be? Well, land, it's dry, cool, north, so it's a continental polar air mass. Down in the south, currently there's a tropical depression down here, maritime tropical air masses. Very humid, warm. Desert southwest, continental tropical air mass, dry. You can get air masses that are over the water to the north. There might be a polar air mass, polar maritime, moist. And you can get Arctic air masses as well. The differentiation between each of these is what becomes interesting. When you're in the middle of an air mass, your weather is going to be pretty uniform. It's the transition that makes life interesting. So fronts are these transition zones. We saw several of them on the map today. What happens along that front? And the front's not going to be an instant little point. It may appear as a point on the map, but it's probably about 100 miles, maybe or less wide. It's a change in temperature, humidity that is going across that front. So a stationary front. I showed you one of those to Missouri, Tennessee, Kentucky area today. Not moving north or south. One side of it, typically towards the south, is going to be warm, tend to have more moisture. And in days, if you had looked at the details, you would have seen a lot of dew points in the 70s, even down to the south of that front. Temperatures well up in the 80s, 90s. Lots of warm air. Well, we know warm air rises. It's less dense than cold air. So part of that warm air is probably going to be lifting over that boundary of cooler air to the north, where you all in Ohio are today. So you may be seeing some high clouds well away from that boundary. The closer you got to that boundary, the lower the clouds would get, the better chance of precipitation. Now, stationary fronts don't stay stationary. They're there for a little while, but eventually they're going to start moving. When they do, they may be a warm front. As we're going to see this week, that warm air, that stationary front is going to come back north as a warm front later on Monday and Tuesday. When it does, that warm air to the south is advancing towards your area in Ohio or mine down here, southeastern Virginia, bringing in more humid, hotter air. It's going to tend to push out ahead of it. That cold air will have precipitation. Maybe you'll see the clouds gradually thicken. Instead of being nice high clouds, they may begin to lower into cumulus clouds. And the cold front, we saw one of those coming through later in the week along the cold front. Remember, cold front's very dense at cold air. So it's going to have very steep slope. It's going to have more stronger vertical motion, more instability typically with it. It's going to push the cold air up. You wind up better chance of precipitation and thunderstorms. Cold fronts, warm fronts typically move from the west along with the lows and stuff. However, once in a while, a cold front will come down the eastern part of the United States. We call them backdoor cold fronts because they come out of the back door. When they do, they bring in maritime polar air, typically coming off the northern Atlantic and down the east coast. They can even bring in some continental polar air, even Arctic air, if they're forming over the northeastern part of Canada. Occluded front. So this is a little different. All right. We talked about a warm front having warm air advancing and a cold front having cold air advancing. Well, there is a case near a low pressure system where that cold air that's been advancing with the low catches up to that warm air that's ahead of it in the warm sector, pushes that air up, so you wind up that where that warm front was moving, there was cooler air ahead of it, but you wind up with the warm air being aloft, and you have the cold air coming in from the west, and the cool air that was ahead of that warm front to the east. If the cold air coming from the west is colder than the cool air that was ahead of that warm front, that's a cold occlusion. If, on the other hand, the air coming from the west, which would happen a lot out in the Pacific area, the Rocky Mountains, was not as cool, you would wind up with the warm air still aloft, but it would be a warm type occlusion, where the air coming in is not as cold as what is leaving. So fronts are characterized by the change in air mass, and fronts form and dissipate. As a front forms, the temperature gradient increases, the winds might be blowing towards it, convergence may occur, maybe clouds will help form it, but that's frontogenesis. Frontolysis is when the winds blow apart, more sunshine, you wind up maybe with a weakening front, frontolysis. So, extratropical cyclones now. Let's go into these. These are significant. They can occur over 1,000 miles. They tend to last 3 or 4 days, not as long as these major regions where these air masses actually occur. These are moving along. The air masses are develop in one area, come out, and then an air mass redevelops back where it was and comes out again. These typically move right along and keep moving. When they last longer, that's when really problems begin to develop. There's what we call the Norwegian cyclone model. It was developed by a gentleman in Norway many, many years ago. But what it looks like on satellite, how it actually, the concepts still apply today. So what happens is we end up with a jet streak aloft. That jet stream causes divergence aloft. So what happens? Initially, along a boundary, stationary front, we get lifting air. As that air rises, it develops convergence at the surface. Lower pressure forms there. So you begin to develop of a low pressure system. A little bit more clouds out ahead of the low, as ahead of the warm front that is now developed ahead of that. You're getting a little bit larger area precipitation, maybe along the cold front, a little steeper, more thunderstorms. With time, that front deepens, the cold front gets stronger, more of a temperature contrast between it and the warm air. Thunderstorms develop a little more. You wind up with a bigger area of clouds, and oh yeah, some of these clouds are getting pulled back to the west, up north of this low, and you wind up eventually with literally a comma shape. And in the latter part, this is when your occluded front forms. And in this case, we have very cold air to the west, it looks like here. So along this occluded front will be a cold occlusion because, yes, it pushed the warm air aloft in this area, but the cool air is not as cold ahead of that. So you wind up with it. And eventually you may even get a secondary low forming. We call them triple point lows that form on the occlusion. And new load might develop in this area down here where the warm front develops again in the cold front. And this can actually propagate. We've seen them propagate across the Pacific, across the United States, across large areas where you get one low develop and a new one develops in a few 3 or 4 days later, where this news convergence develops. So this is the comma-shaped pattern right here. You can see the strong cold front and the comma head up in here. All right, there's another way of looking at these. We call it the conveyor belt model. What you're doing is moving warm, humid conveyors of air and cold, dry conveyors of air. How they move actually shows how this satellite image develops. So the cold conveyor originates to the north of the warm front. It is going to ascend upwards through the low and towards the west. This forms the comma head. It is pulling colder air in and lifting up, so it's forming precipitation. Then there's a dry conveyor, typically originates to the north and west of the low, pulling dry air in, descending. This is going to cause things called a dry slot, where the precipitation will end very quickly, especially right or just along that front, cold front to the south. And you can see that well depicted here. Here's the low off of Carolinas. Plenty of warm, moist air coming up in the warm conveyor. The cold air to the north being pulled in, wrapping around to the northwest, and back up in the higher levels here where it picks the jet stream up, creating the comma head, dry air coming in, descending, causing a drying quicker maybe than we're anticipating. The precipitation might end quicker even before the low passes your area. Weather can be very different depending on what part of the cyclone you are. All of you are in or from Ohio, so let's pick that up here. If you're from Ohio, we're going to move this low over here. The low is going to be centered over Indiana. If I'm in Ohio and moving towards northwest Ohio, we'll say. So if I'm in Ohio and the low is moving to my northwest, I'm going to get into the warm sector. I am going to have some rain as that warm front passes me. May even start out as a little bit of snow, but then it's going to change to rain. Temperatures are going to warm. You're going to say, not bad. And then the cold front will come through, maybe bringing a few flurries off the lakes or even lakes like snow, but also bringing some thunderstorms with it. And one easy way to track this low, we talked in the very first week of class that as the low is moving, pressures drop, so you look for where pressures are going to fall. Lows can form in all kinds of places. There are Lows, a lot of them form out over the Rocky Mountains and move east. Colorado lows, they have access to the Gulf and to the southeastern Atlantic and will pull a lot of moisture in. These Alberta lows, which can be pretty intense sometimes as they're moving along, may produce a very strong swath of tiny bits of very dry snow, but they don't last long because they don't produce a lot of precipitation because they don't have access to all the moisture from the south. Again, here's a typical one if Chicago was in it. We'll take you again. If the low I was talking about, instead of going through northwestern parts of Ohio, went through eastern parts, well, most of Ohio then would never see the warm sector. It would always stay on the cold side. You would always have snow. So forecasting where that low is going in relation to your house is extremely important as to what kind of wintertime precip you're going to have. Winter storms. Winter storms are any storm that has freezing or frozen precipitation with it. Doesn't mean it's going to be heavy snow, doesn't mean it's going to be a lot of ice. It just means one or the other and some of it occurring. Blizzards are a very specific type of winter storm. They must have very strong winds and very, very intense precipitation, reducing visibility less than a quarter mile. That requires this to be all snow. Here you can see winter storms in the different parts of what happens with them. All right. Interestingly, the system I just described is what we call a cold core low or cyclone. Why is it cold core? The coldest air is to the north and west of that particular surface low. The surface low would be over here. The upper low would be back in here, and it would be colder back to the west. So, in other words, you start off cold at the surface, pressure drops fast in that cold air as you're rising up, and the more and more intense low actually develops to the north and west of the surface low. Weaker ones of non-occluded cold air can occur. And then we have warm core. Talked a little bit about the monsoon that forms down in Arizona, New Mexico this time of year. That is a warm core cyclone. Tropical storms, warm core. There are warm core lows that develop over the deserts. Why are these warm core? Because the temperature at the surface is very warm, may not be necessarily humid, it might just be dry. But because it is, it actually pushes the air apart, causing lower density, lower pressure. However, as you go up in that system, the pressure will fall slowly. You actually get higher pressure above these. Where the other one got colder with height and more intense, these get weaker and not as intense. So there are different types. We've talked a lot about the precipitation from the lows and all now. Highs follow these lows or are out ahead of them. They interact with these extratropical cyclones. They may be where the cold air comes in after the low. Maybe they pull in some moisture out ahead of the low. And there are warm core anticyclones as well. Typically, when the anticyclone hits your area, you're going to have nice weather. However, Great Lakes might be a little exception with this because as the high is moving in, the winds are coming across the Great Lakes, and we get a lake breeze. Well, lake breeze, guess what? That means it's going to be pulling moisture off the lakes, picking up, becoming more unstable. The lower part of that air is going to be warmer. You wind up, when it hits the land, it's going to be slowing. We learned that. Convergence forms, you wind up with snow. That's where these heavy snow bands develop. And here is a good example of a sea breeze or a lake land breeze as well. Valleys, mountains have them. If you're a fire weather person, if you were fighting fires, you would need to know these extremely well because your fire, maybe it's working its way up the slope during the daytime with the wind coming up as the heating develops. Oh, at night, Yeah, cold air drains. Now the wind's going in the opposite direction, so the fire might all of a sudden come right back at you. So firefighters really have a critical need to understand how these valley breezes and mountain breezes and how intense they're going to be and how they're going to work. Chinooks, if you're out in the west, particularly Montana or somewhere just east of that, you may get these very intense winds coming out of the west and then down the east slope of the mountains. If they're coming down, we know they're compressing, they're getting warmer, they're getting drier. They literally eat the snow up. Many times they can be called snow eaters. And there have been cases where the temperature rose out in Wyoming area, particularly, at least one case. The temperature was 20 degrees below zero in the morning. By afternoon, it was over 70 degrees. Much drier, extremely dry, but that was all due to a Chinook wind. Santa Ana winds are another form of Chinook. They occur out in the California area. They come down off the mountains as the high pressure develops to the north over the mountains, pushing the cooler air down the slopes towards the Los Angeles area or San Diego area. Gravity pulls that air down. They get stronger winds, get spectacular, dry, very intense winds, and many times, unfortunately, a lot of bad fires. So I think that's about all you need to understand out of this. Let me know if you have any questions.